In this video, we'll be reversing the order of integration. So we have a double integral right here. We want to reverse dx and dy. Therefore, we're going to have double integral with fxy. Instead of dy dx, this time will be dx dy. The first step you want to do is to write out all of the x and y values. So x equals 2 and x equals -4, y equals 8 minus 4x, and y equals 0. Do you understand where I got each value? So for x, it's 2 and -4. For y, it's 8 minus 4x and 0. The second step is you want to graph. So 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Okay, so this graph is gonna be in increments of 2, 8, 10. Begin by graphing x equals 2. Label your line x equals 2 and x equals -4. Well, let's imagine that this is where -4 is. X equals -4. Now we graph y equals 0. Y equals 0. And then we're going to graph y equals 8 minus 4x. This is the same thing as y equals -4x plus 8. So the y-intercept would be at 8. So here. So you rise -4, 1, 2, 4, run 1. Rise 4, 2, 4, run -1. Alright, so this would be the line y equals -4x plus 8. Now, your region would be over here, this region. Initially, you had dy dx. So initially, you had a slider that goes up and down, slides from left to right. Now, you are going to set up an integral with the slider from left to right going up and down. Okay, so set up your integral, write down the values, dx dy. In order to find the upper boundary of dx, you're going to just look at this graph and see, okay, what line determines where the x-axis ends in this graph within the region. So the x-axis finishes right here for the upper boundary. And this, we use the lines y equals -4x plus 8. Therefore, in order to find the upper boundary for dx, you're going to solve for x. So x, you subtract 8 on both sides, you get y minus 8 equals -4x, and then divide -4 on both sides. Therefore, you have x equals y over -4 plus 2, if you simplify it, or 2 minus y over 4. Okay, so here you could write down 2 minus y over 4. To find the lower boundary, you want to see what line determines where the x-axis ends within the region, and it's this line. Therefore, x will equals to -4. Okay, moving on. Finding the upper boundary for y, you have to see, okay, what line determines where y ends? And it's a combination of these two lines, x equals -4 and y equals -4x plus 8. But we know that y equals -4x plus 8, same thing as x equals 2 minus y over 4. So x equals 2 minus y over 4. So it's bounded by 2 lines, and x equals 4, negative 4. You can set x as negative 4 and plug this value in here. So you have negative 4 equals 2 minus y over 4. And if you divide, no, don't divide. If you isolate y, so you subtract 2 on both sides, so you have negative 6 equals negative y over 4 times 4 on both sides. You have negative 24 equals negative y. Divide negative 1 on both sides to have a positive y. Y is equal to 24. This will be your upper boundary. Now for your lower boundary, we know that the line that determines the lower boundary for dy is going to be y equals 0. Therefore, lower boundary will be 0. Now, once you erase everything that is in the way of the answer, you can box your answer, and this will be the reverse order of this double integral.